Tell me anyone, is the screen visible?
Yes, sir.
Yes, sir.
The screen is visible. Actually, it's very simple to just tell me. Just- Okay. In the last class, we did few examples based on some basic formulas in formulas part one, and in the last part of the last class, I gave you two properties. One is ddx of k into fx is equal to k into ddx of fx. That means when we differentiate a function and any constant is associated with the function, then we can write the constant outside the operator. Now, this was the first property given in the last class. And the second one, differentiation of uh, two splitted functions. Splitted means two functions fx and gx, which are maybe in addition or subtraction form. Differentiation of fx plus gx or differentiation of fx minus gx. So if two functions are there in addition or subtraction form, simply we need to differentiate function. That is ddx of the differentiation of the first function plus or minus ddx of the second function. That is differentiation of the second function. Simply just two functions. If there are two functions to differentiate, which are in addition or subtraction form, we need to differentiate uh, separately. That is differentiation of the first plus or minus differentiation of the second. And the first one property was, if any constant is associated, that is multiplied with a function, then we can write the constant outside the operator. Thus, these two properties were given. And x to the power n related few examples given in the last class. Let's discuss uh, just applications of the two properties. Here in the example one, you see uh,
Sir,
ddx of 2
hello,
into
sir.
x to the power 3. 2 into
Hello,
x to
sir.
the power 3. So this is x to the power 3 part is um, it is x to the power n formula, no doubt. But 2, which is a constant, it is not x. That means constant. So since 2 is multiplied with x cube, if x cube is assumed to be a function, 2 is as constant, and then 2 we can write outside the operator, outside ddx. Then we can write this function, rewrite 2 into ddx of x cube. Thus 2 as it is, and differentiation of x cube using x to the power n formula, n into x to the power n minus 1. That means 3 into x to the power 3 minus 1. 3 minus 1 means 2. So 3x square. So result is 6x square. So x to the power n formula. Actually, the formula for differentiation is applied here, x to the power n formula, which was used in the last class in several examples. And this is what that we have used the first property is given. When a constant is multiplied, constant we can write outside the operator. ddx is the operator, and outside the operator we can write the constant. X to the power n formula, it's simple. Next, Number 2 example. Uh, Here you see uh, ddx of ax square plus bx. Here plus sign is there. So ax square plus bx. That means two functions fx and gx can be considered. So to differentiate, we need to differentiate separately. Very simple way. ddx of ax square, that is differentiation of the first ax square, plus differentiation of the second, that is bx. That's applied here. ddx of the first plus ddx of the second. Differentiation of the first and differentiation of the second. Now ddx of ax square, we have to go to the formula. Now a is constant, so constant we can write outside the operator. So this a is written outside ddx of its left x square. So ddx of the first, ddx of the second. So ax square, a is constant written outside. Now ddx of x square, and ddx of x square, x to the power n formula, and it gives us twice x, n into x to the power n minus 1. If you use, you will have twice x, n into x to the power n. N means 2 here, 2 into x to the power 2 minus 1. 2 minus 1 means 1. So 1 exponent is not written here. So ddx of x square is twice x. Now in the second one, ddx of bx. B is constant, so written outside ddx of x. And ddx of x is equal to 1. X to the power, again x to the power n formula. Here x to the power n, n means 1 here. So x to the power n formula you follow, n into x to the power n minus 1, you will have x to the power 0, and x to the power 0 means 1. So differentiation of x is 1, and here differentiation of x square, twice x. So twice ax plus b is the result. And in the third one, in similar way, ddx of 3 root over x plus 5 by root over x. It is the same property. So at sum of two functions. First one is 3 root x, second one is 5 by root x. So same property you have to apply. So derivative of the first plus derivative of the second. So ddx of 3 root x plus ddx of 5 by root x. So ddx of 3 root x, 3 is constant, so it is written outside, and ddx of root x left. Plus 5 by root x. So 5 is constant. So 5 is written outside the operator. So it's left ddx of 1 by root over x. 1 by root over x means x to the power minus half. 1 by root over x means x to the power minus half. Now x to the power n formula we can differentiate. So 3 as it is, ddx of root x, as I showed you yesterday last class. Root x, derivative of root x to the power n formula using, we get 1 by 2 root x. Differentiation of root x is 1 by 2 root x. Is like formula also you can remember this. ddx of root x 1 by 2 root x. X to the power n formula you can use x to the power half. That means root x means x to the power half. So n is equal to half. Then so ddx of root x is 1 by 2 root x. And here this is x to the power n again formula here, the second one. N means minus half. So x to the power n formula you can use n into x to the power n minus 1, and by doing this we get x to the power minus 3 by 2. And denominator 5, so 5 by 2 as a constant, it remains here. So this is the result of differentiation. So basically what properties, two properties are given in the last part of the last class. The few basic examples discussed using x to the power n formula and two properties. And these are the applications of that two properties. Now in the third one, same way, ddx of a into x to the e to the power x plus b into a to the power x. So sum of two. So ddx of, that is derivative of the first plus derivative of the second. So derivative of the first, a is constant. It is not after all x. So a is constant. A is written outside the operator. E to the power x left plus ddx of b into a to the power x. So b is constant written outside. So ddx of a to the power x. ddx of e to the power x is the formula. Derivative of e to the power x is always e to the power x. So as per our formula, we got e to the power x. In the second one, ddx of a to the power x. There is again a different formula, a to the power x. Derivative of a to the power x means a to the power x log of a. So exactly its formula. This is the formula, a to the power x log of a. Thus this result is written from the given standard formula. And now in the last example, you see the dx of differentiation of uh, 2 log x plus 3 into 2 to the power x. As per the formula, we can move the dx of the first, that is 2 log x, plus the dx of the second, that is 3 into 2 to the power. 2 is constant here, so 2 is written outside the operator, so it's left the dx of log x. And the dx of log x, base e, it is the formula, and log x derivatives we know 1 by x. There's the formula, it was given in the last formula. Derivative of log x is 1 by x. So derivative of log x is 1 by x plus 3 into 3 is constant outside. So ddx of 2 to the power x. 2 to the power x means it is, we have to follow the formula a to the power x. So what is the formula for a to the power x? That means derivative of a to the power x used in the above example. Ddx of a to the power x means a to the power x log of a. Now a to the power x, here a is any constant and positive constant, and x is variable here. So it is exactly same form. It is derivative of 2 to the power x. That means a is equal to 2 here. So we have to use a to the power x formula. Derivative of a to the power x formula we have to use here. So as per that formula, a to the power x log of a, that means 2 to the power x log of 2. So as per the formula, we have got this results. So mainly we are familiar with these two properties. That is, when a constant is multiplied, we can write the constant outside the operator. And secondly, if two or more functions are there in addition or subtraction form, then to differentiate the function, we have to move term-wise or function-wise. Derivative of the first plus or minus derivative of the second, again plus or minus if any, derivative of the third, and so on. So just we can follow the properties. After that, we can use our relevant formula. Now see, this is the next page. Few trigonometric formula. So that I am giving few formulas in part 2. In part 1, 5 formulas were given, very fundamental, and in this part 2, I am giving the 6 basic, very fundamental formulas of trigonometric function. Differentiation of sin x is equal to cos x. You have to remember all the formulas. Without remembering the formulas, you cannot go ahead a single step at the time of solving numericals in differential calculus. It's in every formula you have to remind. So derivative, first one, derivative of sin x is equal to cos x. Second, derivative of cos x is equal to minus sin x. Third, derivative of tan x is equal to sec square x. Fourth, derivative of cot x minus cosec square x. Fifth, derivative of sec x is equal to sec x into tan x. Derivative of cosec x is equal to minus cosec x cot x. These are the result of differentiation. All these results can be obtained using the definition, using the definition. So these are formulated using the fundamental concept of definition, uh, derivative using definition. So these were formulated. So as I told you, using the definition to differentiate the function is very laborious. So we cannot go through that fundamental definition to differentiate this, because uh, just for formulation this concept was used. So using this formula we can differentiate the functions related to direct trigonometric ratio. Again, there are some formulas related to inverse trigonometric functions. So before going to enter some examples, you should be familiar with a new rule. That rule is product rule. As we discussed in the last property, that when two functions are or more than two functions are in addition or subtraction form, then uh, we to differentiate that function, we have to differentiate the function wise, the term wise. And if the function is of the product form, if two functions are there in product form, then to differentiate is another rule is there to be followed, and that rule is this one: ddx of fx into gx is product of two functions. Then we have to follow up this rule. Fx is the first function, gx is the second function, suppose. So as per this rule, simply we cannot differentiate differentiation of the first into differentiation of the second. We cannot go through like this. We have to go through this specific property. First function as it is into derivative of second function, ddx of second function, plus, it is strictly plus, always plus as per this rule, plus second function gx as it is derivative of first function. So this is the rule to differentiate a function which is product of two functions. A function which is product of other two functions. To differentiate this, we have to move as per this rule. First function as it is derivative of second function, plus second function as it is derivative of the first function, which is called product rule. Here in this example, number one, you see ddx of x square sin x. You know, x square sin x as a whole, if you think to use formula, you will have no formula. You will have no formula because you have x square uh, formula alone using x to the power n formula. Again, you know derivative of sin x because there is a formula. But as a whole, x square sin x, there is no formula of this structure. So you have to think x square is uh, algebraic expression and sin x is trigonometric expression. So algebraic expression and trigonometric expression. So two different functions. One is algebraic, another is trigonometric. So they are in product form. They are in product form. They are multiplied. So we have to move through product rule. So x square is the first function and sin x is the second function. So as per the product rule, we have to write the step. How will you write the step? As we got in above here, uh, first x square and second function is sin x. So x square is the first, sin x is the suppose second function. So as per this rule, first function x square as it is. First function as it is, ddx of second function, that is sin x, plus second function sin x as it is into ddx of first function x square. So as per this product rule, we have to write this step. First function as it is, derivative of second function, plus second function as it is, derivative of first function. So this rule we have written using the product rule. In this example, we have written this step using product. Now simply we have to write the result. X square next step, x square as it is here, ddx of sin x, that is derivative of sin x. Derivative of sin x, you know, as per this formula, cos x. So derivative of sin x is cos x, plus sin x here as it is, derivative of x square. Differentiation of x square is what? Twice x. Twice x. So result is twice x into sin x. Twice x into sin x. So it's the twice x into sin x. That is. So similarly, the second example you see ddx of 2 to the power x into 10x. You know, as a whole, you do not have any formula. But 2 to the power x is exponential function, and 10x is another trigonometric function. So it is product of two functions. So you have to move with product rule. So 2 to the power x is the first function, 10x is the second function. So first function as it is, derivative of second function 10x, plus second function 10x as it is, derivative of the first function 2 to the power x. So 2 to the power x as it is, 10x derivative sec square x, and 10x as it is, 2 to the power x derivative a to the power x formula. So a to the power x log a, that means 2 to the power x log 2. So to write the results of the differential, you do not have any problem. Just you have to uh, try to write yourself the results. And properties, you need to understand that if the two functions are there in product form, how to use the product rule. If they are in addition or subtraction form, how to move. But if you know these properties, then to write the results of the differentiation, you do not have any problem. Just you have to write the results of the differentiation using formula. So you need to practice yourself little bit how to write the results of the this basic examples of differentiation. Okay, that's all for today. Next will in the next class I will continue with different set of examples. Thank you so much.